Today we are going to continue talking about logic. And we're going to build on the ideas from last time and work with truth tables. Alright, last class we saw specific examples of statements and how to negate them. For instance, we saw the phrase, "I teach math," which is true for me, and the negation of that is, "I don't teach math." If I were to tell you the phrase, "I don't teach math," I am lying to you. We want to associate lies with false statements. We can symbolize statements and their truth values in the following way with the truth table. What I have here is I have a statement P, and P can either be true or false. So I have both of those options underneath P. Now, depending on what P is, I know what the value of not P is. For instance, reading across the row, when P is true, not P has to be false. This is because the negation changes the truth value. So if P were false, not P must be true. This is the building block that we will use for negations. Now suppose we wanted to look at build the truth table for and. We combine two statements with the word and. So the basic building block for two statements has a column for P and a column for Q. What we have listed here are all of the possibilities of the truth values of P and Q. For instance, both of them could be true, one could be true and one could be false, or both of them could be false. Now, if I wanted to know what the truth value is for P and Q, we have that if both P and Q are true, then P and Q, that mathematical compound statement, is true. This relates to the statement last time where I said I teach math and I live in Pennsylvania. However, if P is true and Q is false, the compound phrase combined with "and" is a false statement. Again, with a specific example, we had I teach math and I am a boy, but that is not a true statement. Similarly, if P is false and Q is true, P and Q is a false statement. Lastly, if both P and Q are false, then the compound phrase P and Q is also a false statement. For instance, I could say, I am a boy and I'm from Mars. Both of those are false statements for me, and if I were to tell you that compound phrase, it would be a lie. Therefore, I am a boy and I'm from Mars is a lie and hence false. This is the building block that we will be using for and. What's important here and what you should start saying in your head is true and true is true. True and false is false. False and true is false. False and false is false. These building blocks should be memorized. Now let's look at the building block for or. Again, we combine two phrases with the word or, so I look at all of the possibilities for P and Q with their truth values. They could both be true, one could be true, the other could be false, in which we have two cases, and they could both be false. Now, the truth table for P or Q, based upon the values of P and Q, are the following. True or true is true. True or false is true. So I'm reading across each row. I'm now at the third row, and I have false or true is true. And lastly, false or false is false. So let's just give an example. Last class we had an example that combined two statements with or. It was, I teach math or I am a boy. That corresponds to P or Q, where Q is false and P is true. So if I were to say, I teach math, or I am a boy, I am not lying to you, therefore that statement is true. However, if I were to say, I teach English, or I am from Mars, that is false. So therefore, that is an example of when false or false is false. All right. Once we have these three building blocks, and by the way, we will have one more later on, but for now, we're going to learn how to work with these three building blocks for more complicated compound phrases. Once we have these, we can build a truth table for more complicated compound phrases such as the one listed here. So this is, it is not the case that P and Q. So depending on what P and Q are, this is actually a sentence. It's a statement. We see two statements, so we will go ahead and write down all of the possible choices for P and Q. We want to abide by order of operations, and so I'm going to first figure out what the truth value is for P and Q. Well, this is actually just one of our building blocks. We already know that true and true is true. I'm basically just copying this down. True and false is false. False and true is false. And lastly, false and false is false. So again, we're reading across each row. Now that I have the truth value for P and Q, I'm left to negate that to find our answer. So, reading across each row, if I know that P and Q is true, then not P and Q must be false. So you can see that from the red column to the purple column, we just switch the values, because that is what it means to negate a phrase. All right, let's look at another example. This is an example where we have three statements. I want to write down all of the possibilities of P, Q, and R being true and false together. And what we see here is that we actually have 8 different rows. It turns out that if you have n statements, a truth table will have 2 to the n rows. You might need that for your homework. Alright, so we begin by writing down all of these different rows. This is something that you can copy down, or you'll be given this on an exam. Alright, following order of operations, we would like to find the truth value of P or Q. So, we forget about the column for R, and we simply look at the values for P and Q on the left. The first two values for P and Q in the first row is true and true. So true or true is true. And I go through and I look at all of the different values. For instance, the third row, in fact the third and the fourth row are the same, and that is true or false. But true or false is true. The fifth and the sixth row both are false or true, which is a true statement. And the seventh and the eighth row are both false or false, which is a false statement. Alright, now that we have P or Q, what we can do is we can negate this. So we take all of the values in the P or Q column of our truth table and we change them to the opposite. What we have right now is the truth value for the leftmost side of our example. What's remaining is to figure out the truth values for not R. Okay, so we go through and we find the truth value for not R. We forget about everything else in the column except for R, and we change those values. Lastly, we want to find the truth value for not the statement P or Q and not R. So I look at the last two red columns and I'm combining these with with an AND symbol. So for instance, the first row gives us false and false is a false statement, false and true is false, false and false is false, and we continue using our building block until we've finished the truth table. For instance, let's just look at the last row. We know that a true statement and a true statement combined with and, so true and true is true. All right, let's do one more example. This is a little bit easier because what we're told is we know for sure that P is true, Q is true, and R is false. So instead of doing a truth table for this whole expression, we only need to do it piece by piece. So I'm going to substitute in the values T for P and Q and F for R. All right. Order of operations tells me to do the innermost things first, so I'm looking at not true and not true. But I know that not true is false and not true is false, so I really have false and false, or false. I know that false and false is a false statement, so my overall problem is not the statement false or false. I work on the parentheses first. I know that false or false is false, so now I'm really looking at not false, which is true. Okay, so we did those examples pretty quickly. Please go through and try them on your own, pausing the slides when necessary.